Hello students. Now let's understand HITS algorithm. Now HITS stands for Hyperlink Induced Topic Search Algorithm. Here we need to find two things. One is the hub score and second is the authoritative score. So these are the two scores that we have to find for each node. Okay, so here we have to find for each node. Hub score we are going to represent with a vector called as U and authoritative score with a vector called as V. Okay, so these are the two vectors that we are going to represent for any given matrix, and we need to keep updating these vectors. Now in exam the question will be given in this way. Here the adjacency matrix is given and you need to find the hub score by applying HITS algorithm for the iteration is equal to 6. So we need to perform some repetitive task to calculate the hub score and authoritative score. Okay. Now, sometimes instead of adjacency matrix, they will be giving you a graph. Okay. So if the graph is given, so you have to convert that graph into adjacency matrix. Now, what exactly, how you're going to create a graph here? So for example, if I show you this particular graph, so there are, let's say, nodes, 4 nodes, A to B to C and D, right? So here, if you see, one stands for if there is an edge from this source node to the destination node. So if I call this first line as A, B, C, and D, here also A, B, C, and D. So you can clearly see that there is a node from A to B, A to C, A to D. So it means that I have edges. The graph has edges from node A to B, A to C, A to D. Similarly, node B has edges to C and D. So node B has edges to C and D. And then node C has edges to A and D. So node C has edges to A and D. And then D has node to itself. So it's a self loop. So this is how a graph can be represented for this adjacency matrix. So in exam, if the graph is given, you have to create an adjacency matrix out of it, or directly the adjacency matrix will be given. So any of this is given, you have to write the adjacency matrix and perform the operation. So now, as I said, the adjacency matrix is given. We have to consider the hub score, hub vector, and authority vector. So the first step here is okay. So first step here is you have to create the table where you can clearly see what are the out degrees and in degrees. Now we know that hubs are nothing but the nodes which has maximum out degrees, and authority nodes are the nodes which has maximum in degrees, right? So here if you see node 4, total 4 edges are coming to node 4, and I can clearly say that node 4 is a authoritative node. So if I find out the in degrees of the node, so there are total 4 nodes. So the matrix which is given, I've created a graph out of it, out of this matrix. And just for my understanding, let me just write the out degrees and in degrees of each node. So node 1 has 3 out degrees. That means from node 1, there are 3 out edges, and there are only 1 incoming edge from node 3. So it's in degrees 1. Similarly for node 2, node 3, and node 4. And I can clearly see that if I want to check the in degrees represents the authoritative score, which clearly shows that N4 has the maximum authority. So N4 is the highest node having maximum authority. Whereas for hubs, N1 is the highest hub score because maximum out degrees are going from N1. Now this is for my understanding, but we need to check it from the problem HITS algorithm point of view. So here the algorithm calculates the authority score and hub score using this formula. So you have to note down this formula. The V matrix, which is authoritative score matrix, is calculated with the help of the transpose of the given matrix into the hub vector. That means to calculate authoritative score matrix, you need a hub vector. And to calculate the hub score, you need authority vector. So the formula for calculating hub score is the adjacency matrix into the authority score. Now, these two formulas we are going to use to calculate the authority score and hub score. Now, we are going to solve the initial step. Now, initial step means we need to form these vectors. We need to get the values of this vector. But we can see that to calculate authority vector, we need hub score. To calculate hub score, we need authority score. So how do we start? Because to calculate any one vector, we need the help of other vector. Now here we are going to assume something in the beginning. So in the beginning, what we're going to do, we're going to assume that, let's say that all the nodes have initial hub score. Okay, so here I can say that all the nodes has initial hub score. So here my u vector will be all values 1. For all the nodes, the values will be 1. So I am assuming the hub score. That means I'm assuming that all my nodes are hub nodes, and that's why the score of all the nodes will be 1. So this is how I can get a vector out of it. That means all the values will be 1 in this vector. So we have total 4 nodes. So all the nodes will have value 1 for that matter. And this is which value? This is hub value. Because we know to calculate authoritative score vector, we need a hub score. And we are assuming this value initially. So I assume that all are 1. And now multiply this with the transpose of the matrix. So we know how to calculate the transpose of this matrix. We know that the row will become column and columns will become rows. So here 0, 1, 1, 1 will become first column, then 0, 0, 1, 1 will become second column, likewise. So you need to get the transpose of this matrix like this. Okay, so here if you see, we need to get the transpose matrix. So this is the very first step. I assume the value of u as all 1 and I perform the transpose of the given matrix. So this matrix transpose is this. And now I multiply u into 80. So u into 80, which means the multiplication of these two matrices, that will give me the final score, which is my V score. V score, as I said, it's an authority score. So this formula we have applied initially. So initially we're going to calculate authoritative always, assuming all are hubs, right? So all are 1 and adjacency matrix ka transpose. And then we get authoritative score. Now, once we have authoritative score, we can use that to calculate the hub score again, because initially we assumed. Now we have to get the actual value of hub score. So now we will take this new value which we got from authoritative vector and we multiply with the original matrix, which is your A matrix. So this matrix and the authority score matrix, you multiply them together to get the hub score now. Now, this is what the hub score which I got, and this is what the authoritative score I got. I hope this step is very clear, and this is called as initial step. I'll repeat again. What we did is the formula that calculates the hub score authority score is this, where first we need to calculate the authority score. How to calculate authoritative score? It is with the transpose of the matrix into hub score. Then we are going to use this authoritative score to calculate the hub score by multiplying the original matrix. Now, initially we don't have any of these vectors, so we assume the hub score as all ones, and then we multiply it with the transpose of the given adjacency matrix. Now, once this is done, we use that value, the vector that we got from authoritative score, we use that and multiply it with the original matrix to get the hub score. And write down these values on the nodes of your graph. So you can see N1 has hub score 7, which we are getting from this vector. So 7, 6, 5, 4. Hub score 7, 6, 5, and 4. And similarly, authoritative score of node, all the 4 nodes. So authoritative score of N1 is A, N1 is 1, N2 is 1, N3 is 2, and N4 is 4. By looking at this graph, you can clearly see that this node has a maximum hub score, whereas this node has the maximum authority score. Even this is coming as hub score because we have not gone through the iterations, multiple iterations. So we need to understand what are the other iterations that we have to perform. Now, this is the initial step. So again, I'm repeating, this is just an initial step. We have not started with the iterations. Now here onwards, now we'll start with the iterations. Now what iterations means? So here the k value is given as 6. That means 6 times you have to perform some operation to get the final value, because I can clearly see somewhere the authority score is not coming properly. It's showing authority, but it is also showing this node as having highest hub score. So we'll have to check that and understand what exactly do we mean, how can we calculate the score. So let's go with K1. So first step is we are going to calculate for K1. Now what is this K1 step means? K1 step means whatever hub score and authority score that you got from the previous step, just write them down. Okay, and as of now, this is what the score I got. Now in K1, you are going to sum the squares of these values. So sum the squares of the hub scores, right? So sum the squares of the hub score. That is your currently the value that you get, which will be used to calculate the new hub score for these nodes. Similarly, to calculate authority score, sum of the squares of these value. So this value will be used to calculate the new hub score of all the nodes. So let's take example of authoritative score. So in the previous example, in the previous step, we got authoritative score as 1124, which we forwarded here, 1124. And the hub score was 7654. So here I have written 7654. Now just perform the summation of all the hub scores, squares of hub scores. So 7 square plus 6 square plus 5 square plus 4 square. So all the squares. So just add up them, you're getting 126. Similarly, authority square, you're getting 22. Once this is done, you're going to update the hub score of the nodes and authority score. Now, how do we update? Take the old score. So node 1's old authority score was 1. Divide it with under root of the new value that you got from the summation. Okay, so here n1 upon under root of 22, 1 upon under root of 22, 2 upon under root of 22, and 4 upon under root of 22. These are the values that you got, which will considered as a new hub score for all these 4 nodes. Similarly, U1, for U1 also you will do the same thing. Divide the value, divide the old score, hub score, with upon the new summation that you got, under root of that. So 7 upon under root of 126, 6 upon under root of 126. So all these will be divided with this new value. And these are the scores that you got. That means these are the new updated hub scores and authoritative scores of your graph. So just write them down. So we will erase these values now and we'll update our node with these new values. So your 0.623, 0.231, 0.535, 0.231 likewise. Now after this, you will be doing the same thing for K2. That means you're going to repeat the step for K2. So for K2, for example, if I want to do this, so I'm going to say, okay, so for hub score, I need to find U2 now because it's K2 iteration. So U2 will be 0.623 raised to power square plus 0.535 raised to power square plus 0.445 raised to power square plus 0.356 raised to power 2. So whatever value you will get, right, whatever value you get, I think it comes around something 0.99, something like that. Okay, and then what you do, you update the values. So n1 will be now the older value of n1, which is 0.623 divided by the under root. Okay, so I can just, so it's under root of under root of 0.99 something, which will, if you see, which will come same as 0.623 something, because under root of 1 will be a similar way. So you will get to see that once you do this calculations, you will get the same values, 0.623, 0.535. So in K2, your values are not getting updated, but they remains the same. So here, though the question is you have to go till iteration 6, you have to stop here itself in the second iteration, because in the second iteration, you're getting the same values. So whatever you did in K1 step, you have to repeat it for the number of iterations till you are getting the same values. Till then, you have to keep repeating the same procedure. So this is what the HITS algorithm is, and you can solve K is equal to 2 on your own, and you can clearly see that the value remains the same. So these values you will get the same. And that is the step where you have to stop, and those will be your final hub and authoritative scores. So thank you so much.